In this lesson, we'll talk about how to approach the only question format you will engage in the quantitative reasoning section of the GMAT Focus Edition, which is going to be a standard problem solving question. So, in the quantitative reasoning section for the GMAT Focus, all 21 of the questions are going to be problem solvings. If you're familiar with the legacy form of the GMAT, it used to have two types of questions, one of which was called a data sufficiency. The data sufficiencies still exist on this test, but they have been moved to the new data insight section. And now all 21 of the quantitative reasoning section questions in the new 45-minute quantitative reasoning section are problem solving in format. And they're always going to have 5 options and 1 correct selection. The choices can include a bunch of different things. They could be numeric values, variables, ranges, statements. They could even involve these Roman numerals if they want to make it a little bit more complex, asking you to determine which of those statements of Roman numerals are true or false. So there's a lot of different ways that they can organize the 5 options, but there's always 5 options in one selection. Now, strategically, you need to note the format of the choices to select an efficient approach and also enable savvy manual calculation. The very first lesson of the quantitative reasoning section was about manual calculation. So you want to always use all of the evidence that you've got in a problem solving question, and that includes how the answer choices are structured to help you decide what the best way to solve is. There is going to be just under 210 as your average per question. It's roughly 2 minutes, to be perfectly honest, now that the data or the GMAT Focus Edition allows for you to go back and review questions. You're probably still going to want to be about 2 minutes, but if you were just averaging out 45 divided by 21, it's kind of around that 210-ish range. You're going to have a hard maximum of 3 minutes for any question, but ultimately, the most important thing is you're going to skip time-consuming questions as needed. It's just since the exam sections are now going to allow you to return back to questions and reselect for up to 3 questions, it's just going to be best practice to, as soon as you encounter a roadblock, make sure you see all of your questions as you move forward. You're going to want to complete a minimum of 7 questions every 15 minutes and always enter an answer, even if you are flagging something for potential return. And upon reaching the end section review and edit screen, you could check your bookmark questions until time expires, but ultimately there hopefully won't be a large number of bookmark questions. That's always going to be an endeavor to try to keep it to under 5, but really, even though they've got this new functionality, we're going to try to avoid using it because it can cause analysis paralysis, and really we want to be working through it in the original order as best we can. Now, taking a look at an example problem-solving question, we first are going to want to set up our scratchpad, listing the choices vertically A through E, including the simple numbers if they're provided, and we'd have them here. We've got 0, 12, 15, 20, 24. Then we want to skip to the end of the problem to identify the sought value and label the choices as such. You don't want to read your paragraph, get to the end, figure out what it's asking for, and then immediately reread the paragraph. This is actually a really quick efficiency that you can build into your quantitative reasoning section, is just eliminate rereading as best you can. And you can see if we skip to the end, the number of bears in the sustainable population at the end of Bill's bear relocation effort is what we're being asked for. And I'd make a little shorthand note above my answer choices on my scratchpad, such as number of bears, end of relo effort. Then you want to read from the beginning, taking notes and completing obviously necessary calculations as you go. The first sentence, honestly, in many of these problem-solving word problems is just unnecessary background, such as this. For many years, a surfeit of bears terrorized Yam Hill neighborhoods. Wonderful. Then Bill moved in, and every week he was able to safely relocate the greater of either 1/3 of the bears or 30 bears. Okay, so we've got greater of 130 or 1/3 or 30 bears relocated until a sustainable population of fewer than 30 bears remained in town. So we'd have until fewer than 30 remain in town, a little greater than symbol there, or less than, I suppose. And then we find that Yam Hill had 270 bears upon Bill's arrival, so 270 bears to start. Then it's just a matter of working through the steps deliberately. So 270 minus 1/3, because 1/3 of 270 is bigger than 30. So 270 minus 90, which is 1/3 of 270, is equal to 180. Then we've got 180, and we discover once again that 1/3 of 180, or 60, is still greater than 30. So we subtract out another 60, and after week 2, there's 120 bears in the Yamhill neighborhoods. Then we take a look and determine that once more, 1/3 of 120, or 40, is still greater than 30. So we can subtract out that 40 from 120 to find after week 3, there were 80 bears left. At this point, 1/3 of 80, even though it is not an integer, is going to be less than 30. So now we're going to subtract out 30. So 80 minus 30 is 50 bears. And since 1/3 of 80 was less than 30, 1/3 of 50 must be as well. And then we'd subtract 50 minus 30 to determine that the correct answer is 20 bears were left in the sustainable population at the end of Bill's bear relocation effort. Now, a more complex quantitative problem-solving question looks like what we have on the left-hand side here with those Roman numerals that I alluded to earlier. But our process is still going to be the same. We're going to set up the scratch pad with the choices A through E, and you'll note that there are interesting combinations of what are allowed for those Roman numerals. And I would recommend that you write out the Roman numeral combinations, because that can help inform which Roman numerals you want to work through first. So we still have to skip to the end to identify the sought value, and we'd be asking for which of the following must be true. And if we're looking at the answer choices and we were working through a scratch pad, we'd write A, Roman numeral 1, B, Roman numeral 3, C, Roman numeral 1 and 3, D, Roman numeral 2 and 3, and E would just probably say all. So now we read from the beginning, taking notes and doing necessary calculations as we go. And we know that X and Y are integers, so no fractions are allowed. And we learned that 3 to the X plus 3 to the X plus 2 is equal to 10 to the Y. Now we want to consider all 4 possible problem-solving tactics, and we'll spend some time talking about them here in a moment. But first is always going to be the technical math, because if you could do the technical approach, it's probably fastest. But as soon as the technical math is neither simple nor apparent to you in the moment, you want to abandon it quickly. You also can consider logical estimation, and you want to do that at every step of every problem, and possibly as a primary tactic if you're not being asked for a specific value. You can also plug in values or model, and you can plug in the choices or backsolve. And you're going to work the problem until one choice remains, and you may not even need to keep going all the way through the problem, because as soon as one value is all that's left, stop, make your selection, and try to avoid fully calculating unless it's absolutely necessary. So we've got our Roman numeral format here. We've noted that we're being asked for which of the following must be true. And we've got this structure of 3 to the X plus 3 to the X plus 2 is equal to 10 to the Y. So you want to consider your best approach in the moment, one of which is the technical math, as we said. But we also could plug in values and estimate. So there's basically 2 potential approaches to this. So our technical math approach is going to recognize that we could factor a 3 to the X out of the 3 to the X and the 3 to the X plus 2 addition operation. And that's going to be equal to 10 to the Y. And then we would discover that 3 to the X times 10 is going to be equal to 10 to the Y. And there's no other factors on the right-hand side. So 3 to the X has to equal 1, and 10 to the Y has to equal 10. Otherwise, this does not work as an operation that would be true. So we know that X has to be equal to 0, because 3 to the X power, for it to equal 1, that means that it's to the 0 power, because any value to the 0 power is just 1, and 10 to the Y is going to have to equal 10, means that there's exactly one factor of 10 in 10, so Y has to be equal to 1 as well, and that would give us our correct answers of Roman numeral 2 and Roman numeral 3. But if you didn't see that technical approach, you could plug in X equals 0 as the most frequently occurring numeral, because we've got the 3 to the X and 3 to the X plus 2 in the original structure. So if you put 3 to the X as 0, that's going to be 1. And then 3 to the x plus 2 becomes 3 to the second power, or 9. And that equals 10. And 10 to the y works if y is equal to 1. But that's the only way. And if we plug in another value for x, like 1, well, even if x is equal to y for Roman numeral 1, then we've got a situation where you're going to have 3 plus 27, because 3 to the first is 3, and then 3 to the 1 plus 2 power is going to be 3 to the third, which is 27. And you aren't going to have any power of 3 that can be produced by a power of 10 on the right-hand side of this equation, except for when there's 0 threes. So you can discover that we're left, once again, with our correct answer of D, because Roman numeral 1 can't work. Because if you've got x is equal to 0 and y was equal to 0, well, then you'd have 1 plus 9 is equal to 1, and that's not true. The only way that this worked was the original technical factorization. But even if you're not able to work through that technical factorization on your own, you can do a little bit of modeling, you could do a little bit of logical estimation, and you can get to the right answer with the tools that are present in the problem and the answers, and even the Roman numerals in this case, with a little bit of logic, remembering that the way that the GMAT focus is set up is it's a test of logic and problem solving using the language of math, using the language of arithmetic, the language of algebra. It is not just a straightforward math test. So let's talk about what we did and what we'll do for every problem solving question. First, we're going to set up the scratchpad listing the choices vertically A through E. We're going to include simple numbers with the choices if they're provided, and maybe even the Roman numerals if they are as well. And you want to note the format of the choices to inform your tactics and your calculation. Step 2 is you're going to want to skip to the end of the problem and label the choices as the sought value or values. You want to note if you're seeking a specific or non-specific value. And you need to beware of what I like to call auto-solving for individual values, because if they're asking you for what is the answer to 6x plus y, don't unnecessarily solve for x and y individually. See if there's a savvy way to get to 6x plus y directly. Then step 3, you want to read from the beginning, taking notes and doing needed calculations. If you see a clear path to solving, take it. It's right there. Even if you think it's going to take a little bit of time, just start working. And often, if you start working, it ends up working out in that like 2 to 3 maximum amount of time that we need to make. But like I said, if you see a certain but time-consuming approach, it usually is going to take under 3 minutes if you begin it immediately. Now, step 4, you need to stop and consider all 4 possible tactics for the most effective and efficient path to solving in the moment. Those tactics are technical math, logical estimation or evaluation, plugging in the values or modeling, and plugging in the choices or back solving. Step 5, work your problem using your chosen tactic until only one choice remains viable, but always be asking, am I progressing to a solution? As soon as that answer is no at any point in the process, estimate a little bit at first, eliminate, guess, and now in the GMAT Focus edition, mark it for possible review if you get to the end of the section in under 20 seconds, but don't get stuck on something. You don't want to proactively skip anything because you're going to have to see all the questions. You can only change 3 problems anyway. You want to avoid that analysis paralysis, but if you do get stuck, mark it for potential return at the end, and yet have to allow a maximum of a single calm reread, recalculate, or tactical reset before you must estimate, eliminate, guess, and mark in under that 20 seconds. And you really want to allow this because there's no better feeling on the GMAT than working through a problem, getting to the right answer, getting to what you believe to be the right answer, looking at the answer choices and going, hey, where's 15? I got 15. And going, wait, let me remain calm. Let me not overcorrect. Let's go retrace the steps once. And if you find where you thought it said 5, but it said -5, or you thought it was addition, but it was actually multiplication, there's no greater confidence boost on the exam. And this happens to everybody at least once in the test. And you want to think of what is known as Occam's razor in these situations. When you felt you were working through it confidently and your answer is not there, you want to assume the simplest solution, which is I either plainly misread something or miscalculated. And that's what you want to focus on. Go find that miscalculation, go find that misread. And if you can fix it, do it. but you have to limit yourself to a single column reread, recalculate, tactical reset. Because if you do it again and you still get an answer that's not there, the wrong answer, then you have to move on because you're probably not going to see it until you go back and look at it with fresh eyes, which is one of the benefits of the new GMAT focus is you could potentially come back and then on that second pass go, oh, actually, I was just really missing a negative throughout this entire process. So let's head on over to our online whiteboard. Take a look at how this is going to look when you engage with your Scratchpad and how it should look for every problem solving question in the new quantitative reasoning section of the GMAT Focus Edition. We have an example problem solving question and we set up our scratch work first. So we got A, B, C, D, E. We got real numbers. So I'm going to write 17, 24, 27, 34, 41 here. And we're going to put a little line over top for what we're being asked to solve. If we skip to the end and we see we're being asked to solve for the sum of the second and fourth odd integers. So I'm going to just write second plus fourth as my question. So we know that the best approach, if we can do it, is probably the technical solution. So if the sum of the first, third, and fifth of 5 consecutive odd integers is 51. So we know that first plus third plus fifth is equal to 51. And we know that they're all odds. We're being asked for the sum of the second and the fourth. So we can articulate the values consciously. So we could say that the first is going to be x, and that's going to allow me to work through everything. So the first could be equal to x. The second would be equal to x plus 2. The third would be equal to x plus 4 because there's 2 between each consecutive odd integer. Then we've got fourth is going to be equal to x plus 6, and fifth is going to be equal to x plus 8. And we always want to focus on what we're being asked for first. So I can see that the second is going to be x plus 2, and we're going to add that to x plus 6. So x plus x means the second plus the fourth is equal to 2x plus 8. And you have to read incredibly carefully because it doesn't say the sum of all of the odds is equal to 51. It says specifically the first, third, and fifth. So that means that x plus 4 plus x plus 8 is equal to 51. So that's going to be 3x plus, because that's x, and x, first, third, and fifth. 4 plus 8, which is 12, is equal to 51. And now I can solve for x. So we've got 3x, and we subtract 12 from each side. We discover that 3x is now equal to 39, which means that x has to be equal to 13. And 2x plus 8 in this situation is going to be 13 times 2, which is 26, plus 8, which is equal to 34 exactly. And that's our technical solution. And if you could see that, great, definitely use it. However, if you do not see that, there is another possible approach. So this is going to be our modeling, back solving alternative. And it even has a little bit of logical evaluation involved. So we got A, B, C, D, E. We got 17. We got 24. We got 27. We got 34. And we've once again got that 41. So we know that we're going to have a second and a fourth that are both odds because it says that they're odd integers. So an odd plus an odd always has to be an even. So that means we can eliminate 1, 2, 3 options based on that illogical evaluation alone. And then it becomes a matter of just plugging in the odds that would add up to 24, but be 2 apart. So even if we tried 24 first, well, we could make the second plus the fourth has to add up to 51, basically. Or sorry, the second plus the fourth has to add up to 24 as a structure. And are the others 51? We can just kind of set that up as some columns. So the second plus fourth to get to 24 is going to end up being 9. Well, not 9 and 13. It's going to be, because it would have to be 11. Well, it's not going to work, is it? Because if I did 9 and 13, that's going to add up to 22. If we did 11 and 15, that's equal to 26. And so it's not even possible to get to a 24 here, actually. And if we look at the others around this, my first would be 9 and then 13 and then 17. And that's going to be way too small for 51. So I can eliminate this logically. And on the exam, I'd go ahead and select 34 right now. But just to prove it out, if we did 34, well, we know again that has to sum up to 34 here. So it's got to be a couple of odds that are a little bit separated from each other. And if we look at that, we could do, we would have to do, well, it's around that 13. So it would be our, you'd do 17, 17. So it'd be 15 and 19. So 15 and 19 here would add up to 34. And if we did 13 plus 17 plus 21, well, if we work that out, that's going to be my 13 plus 17 is 30. 30 plus 21 is 51. And there's my exact answer, doing it kind of a reverse engineered sort of way. And that's the key thing to recognize with these problem solving questions in the quantitative reasoning section of the new GMAT focus. There's usually, especially with word problems, more than one way to solve. And if I just recognize that there was an odd plus an odd, I'm down to either B or D, and I can pretty much just kind of fumble my way to the right answer using some columns, working through the back solving, modeling it a little bit, seeing what the only viable option is. Although, if you can do the technical algebraic structure, it's probably a little bit faster. But that said, the best skill to build, even above manual calculation, for the GMAT overall is flexibility in approach. So when you're going through your practice problems on your own, make sure that you're not just accepting one way to solve. There may be more than one way to do it, and a non-technical approach may ultimately be more apparent to you in the moment. So go ahead and practice your own problem-solving questions as drills to get better at the foundation structure and the only problem that exists on the new GMAT focus quantitative reasoning section.